Good evening. This is meteorologist DT from weatherist.com with the snow podcast for December 18-19 here at 11:30 at night, watching the new GFS come in and looking about what's going to happen here, crisps on the East Coast and the Midwest, and then the cold pattern coming up, and whether or not there's something coming up for the end of the month, and problems with the overall pattern, even though it's very cold, why we're not getting a lot of winter storms here. So let's get right to it. First, we'll take a look at the snowstorm matrix, and you can see not much change from the last update. There's nothing going on the next 3 days for any portion of the eastern half of the country. There's a little bit of activity maybe here the 23rd, 24th for the Midwest, and then the interior Northeast. And then as you can see, but not for I-95, it's still too warm for rain. And then also for December 25, 26. And again, what we've done here is we simply gone back for I-95 from ice to no real snow conditions here. So the snow event day 7, 8, 9, again, not a big deal. Alert color condition blue, which is only for a minor, relatively minor snow event, minor to moderate, over the Midwest and the Ohio Valley. So that's where we stand with the matrix. All right, let's take a look here. One of the problems we have here with the pattern is that the MJO is breaking down here a little bit. If you recall the data, some of you may know this offhand, that the MJO, which you can see right here, okay, it is in currently as of December 18th. It's in phase 7. You can see it right here. Was supposed to swing out through phase 8 and phase 1, which in December and January are both pretty stormy. They end up producing troughs over the eastern United States. But as you can see, you follow the green lines, they go into the neutral circle here by the end of the month, and same thing on the European. It goes to the neutral circle, which means that the MJO is losing its influence, ability to set up a big trough over the eastern United States, and that's one of the problems we have with the pattern. So there's that. Now this is the overall pattern here as of this Monday afternoon, and we can see the polar vortex, very strongly, again, way to the north and moving over Greenland. You can see that there, and then the overall pattern here is coming in this Pacific jet. There it is. This is all Pacific air mass, and there's our southeast ridge here. So we have a little bit of disturbance here, and then the flow goes like this. Well, this is just Pacific air. All the cold air is kept up in here, and that's why we're so warm. Well, okay, we know that it's going to be warm for the next several days. Now this is December 22nd, and what happens is this: the ridge builds up here in Alaska. Notice where the ridge is, folks. People keep saying it's a West Coast ridge. It's not a West Coast ridge. This is a West Coast ridge in here. That's not what we're seeing. All right, this is the West Coast. The ridge is over here in Alaska, okay, which is not a West Coast ridge. So, and what that does is that produces the mean trough, likes to keep it here over the Rockies and the plains in this area. So the energy comes down this way, and it gets very cold. The Arctic air comes pouring out of Canada. But when you have a trough here, you get a ridge here, and that's your southeast ridge. So a lot of this depends on how deep the trough becomes over the southwestern United States, and we'll get to that in just a second. So we can see the image here. This is from the Monday afternoon GFS, European on the left, and the GFS on the right, 500 millibars. The key feature here is this. You see how the European here is digging this down into Utah, Arizona, California, New Mexico. The GFS is not quite as deep with that, and so what that does is, because it's coming down this way, this comes up. You see this? For every action, there's an equal and opposite reaction. So this comes up, and that produces a southeast ridge, which keeps the cold front west of the Appalachians. Now, on the 24th, the GFS does not have nearly the same feature there, and as a result, because this is not as strong, this is not as strong, and the cold front comes through faster across the East Coast on the evening of the 24th into the 25th. Now this is the GFS here from the new one, just came out here, valid for 11 a.m. Christmas morning. Now technically, maybe this is the rain snow line here, so it's possible that the rain could end as snow Christmas morning. Maybe. We'll see. Don't get too excited about it. It's not a big deal. All right. This here shows our temperatures ahead of the cold front here, and you can see how warm it is up and down the East Coast from Maine to Georgia. And you can see the brutal cold air developing over Montana and Minnesota, a place like that. This is pretty impressive stuff. Look at this. Wow. Pretty impressive, to say the least. So we know that's coming. Now, this is the GFS from the 12Z run on Monday afternoon. It's raining here on the 21st. You can see the rain's coming in, a lot of rain. We could use the rain, so that's fine. That's all good. Then what happens afterwards, the European here is much slower. Now this is December 25th. Look where the cold front is here on December 25th. The cold front's back over the Appalachian Mountains. Now this is all snow in here, but over here this is warm and rain. So, and then finally on the 26th, in the morning 26th, it blows on through. Again, it might end as snow over some of the mountains here, but this is essentially rain showers ending as snow in the mountains, rain on the coast at the 26th. So it takes a long time to get through, much longer than the GFS does. And of course, you go further out in time, the European is even colder, the 26th and onto the 28th, the massive Arctic high coming eastward. But this is the GFS now here for the 24th. So you can see that GFS is fast with the cold front. The purple line represents technically the rain-snow line at 7 a.m. in the morning of the 24th of December. But as you can see, the GFS wants to develop a little bit of a wave here on the front. Okay. Now initially with the cold air in place, this looks like you can see this is a rain-snow line. So this would be DC snow, maybe Charlottesville snow, Roanoke, Bluefield, Beckley, up into northwest Virginia, maybe western mountains of North Carolina, right along the coast, right along the boundary of Tennessee. So that's 1 a.m. on the 25th. All right. But by 11 a.m., all the warm air is surging northward again because the front hasn't come through. So the wave of low pressure here causes the front to lift northward. And now the snow has gone over to rain in New York, in Washington, in Philly, in Boston, well, in Baltimore, and places like that. So again, the GFS, even if it is snowy, is only for a few hours on Christmas morning over southwest Virginia, western Maryland, western, maybe the Shenandoah Valley in Pennsylvania. But eastern Pennsylvania goes over to rain, and so does Virginia, and so does Maryland and Delaware, and New Jersey, and New York, and so on and so forth. So not a lot to get excited about. You look at the temperatures. Now, this is the ensemble. Obviously, the operational one's very different because the European keeps that front way to the west through Christmas. So the European is a lot warmer in Connecticut and Virginia and North Carolina and New Jersey. But if you look at the ensembles, they're not that far off. For example, in Richmond, you know, the Monday morning on Christmas morning, it's 36 degrees on the GFS. Here it's 44. Well, that's not terribly far off. 39 in DC, 32. 24 in Pittsburgh, 28 on the European. New York City is 37, 39, 36. Okay, that's not terribly far off, and so on and so forth. So it's, you know, they're fairly close to the ensembles. It's the operational models which are fairly far apart, the temperatures. Now let's take a look what's going on in the pattern here. This is now Christmas morning on the European. So this is the slow model. And you can see there's a strong ridge, very nicely centered right in here. And there's our polar vortex, which is really far to the south. But the trough axis is positively tilted. See this? Southwest to northeast, positively tilted. So the low pressure here tracks up this way. Now, if this was all further to the east, let's say the trough axis is here, the low pressure would track up the coast and you get a snowstorm. But you don't get that. If you look at the large scale pattern, looking at the hemispheric, we can see there's our polar vortex right here. But here we have, over Greenland, we have a positive NAO. There's no doubt about that. We have no Greenland blocking at all. We have a nice ridge here. So we have a negative EPO into Alaska and a positive PNA. So that's good. But the Arctic Oscillation is at best neutral at this point. So it's not a great snowstorm pattern at all. And the trough is way too far to the west to really be a pattern for the East Coast. Now, you have to look at all these things together. You can't just focus on one atmospheric pattern. Here's the temperature for next morning, Christmas, the day after this Christmas morning. You can see it's down to 25 in Richmond, teens in the Shenandoah Valley in western North Carolina, a lot of teens in Pennsylvania, West Virginia. Pretty cold morning. This is on the 26th. There's a GFS ensemble. Again, this is from this afternoon. Also pretty cold. Here is the new one for the 30th. Going into the 31st, it's already in the teens. It's even colder than that on the morning of the 31st. So really quite a cold pattern coming up here. Longer term, we can see slow change in the pattern. Now, we talked about how the NAO is strongly positive. Now, here it is still a big upper low over Greenland, so the NAO is still positive. There's our ridge bringing the cold air. So it's a cold pattern, but there's nothing in the southeast here which shows any sort of development. It's just a cold pattern here, and this like this, and there's no phasing going on here at all. So if there's any energy in the southern jet stream over California, Arizona, it's not going to catch or phase. We're not getting the necessary blocking pattern here over Greenland. So it looks cold and dry for the last several days of December. And you can see how cold the temperatures are. Look at this. These are temperature anomalies for Friday afternoon, December 29th. You can see it's brutally cold, 7, 8 degrees below normal in Virginia, North Carolina, New England even colder, minus 11, minus 13, Wisconsin, Minnesota, Montana. It's cold everywhere outside of the Rockies. Really cold. And if we look at beyond that, January 1st, now here we're seeing something a little better. We're getting, let's see this feature here. Now this is the polar vortexes here. We're beginning to see some height rises here. So maybe the NAO is going negative at this point, or at least neutral, maybe. So that's interesting. And we're getting more of an Arctic oscillation going negative up in here. So we have a second surge of cold air coming in this direction, some sort of reinforcing cold front. So maybe something will develop with that. But overall, the pattern is not great for East Coast winter storms at all. We have to get the things to change. We have to get the NAO in Greenland to go at least neutral or negative. We have to get a stronger Arctic oscillation. Otherwise, it's just a large, very cold Arctic air mass coming in after Christmas, and most of the country is really going to freeze here. A very, very cold east of the Rockies for the entire last week of December. And finally, you can see here, this is even January 2nd. Look how cold it remains. That's a large, impressively long duration cold air mass. This is the DT. I'll catch you on the Facebook page and on the Twitter account. Talk to you next time.